Okay, so this video is going to talk about how to find the union when given two inequalities. So essentially we're going to be solving these two inequalities, and we want to draw our graph showing the union of these two. Now we know it's going to be the union because that is what OR represents. So there's two variations of this problem. You can either draw the union or the intersection. If you're given the word or means union. If you're given the word and, that means an intersection. And it's important to understand the difference of both of those. And an intersection means you want the space that they both share, the solution space that they both have. If you want a union, you're literally taking, hey, this answer and this answer, putting them both together, one big answer. All right, so what we're going to do is we're going to solve this equation. We're going to solve this equation, and we're just going to graph both answers on the same number line. So first we do need to solve these equations, and we are solving them for x. So using our solving equation skills, if I'm solving this for x, since I only have one number that's on the left-hand side, I'm going to move my x's over to the right. This is a positive 6x, so I'm going to do the opposite and subtract it on both sides. 6x minus 6x cancels, so let's drop down to minus 4, less than. 2x's minus 6x's gives us negative 4x's. Now, in order to get x by itself, we just need to get rid of the negative 4, and we do that by dividing out the coefficient. Now, there's one important rule to remember when it comes to solving inequalities, and that is when you multiply or divide by a negative, you must flip the inequality symbol. So our inequality symbol needs to go the opposite direction then because of that specific rule. Otherwise, continue your calculations. Negative 4 over negative 4 cancels, leaving us with x. Negative 4 divided by negative 4 is a positive 1. Now we are typically used to reading inequalities from left to right, our variable being on the left, our number being on the right. So since this is moved around the other way, I'm going to flip this. So essentially think about picking this up, flipping it around to the other side. So the x on this side, the 1 on this side, it's pointing to the x, open to the 1. So it still needs to be pointing to the x, open to the 1. So this reads x is less than 1. We're going to pause there while we solve our other equation. So this one's a one-step inequality to solve. All we have to do, since this is negative 3 times x, we do the opposite and divide. Since we are dividing by a negative, again, our inequality symbol is going to have to flip once again. That's only when you multiply or divide by a negative. You multiply or divide by a positive, you're good. You don't need to flip it. Negative 3 over negative 3 cancels, leaving us with x is greater than or equal to negative cancels with negative. 9 divided by 3 is 3. So our two solutions, x is less than 1 and x is greater than or equal to 3. So we're going to draw both of them on the same graph. So we're looking at the number 1 and we're looking at the number 3. Two important things when it comes to your graph with inequalities. What kind of dot do you have and what direction do you shade? So if you have the less than or greater than symbols, that is an open dot. If you have the less than or greater than or equal to, that is a solid dot on your number. Okay, solid dot, you're including that number. Open dot, you are not. So if I want everything less than 1, it can't actually be 1, but everything less than 1. So that means 1 would have an open dot because we don't actually want to include the 1. But if we look here, 3, x can be greater than or equal to 3. So since it can equal 3, we put a solid dot on 3. So make sure you do pay attention to the difference in those two. Otherwise, looking back at x is less than 1, we want everything less than 1. That is everything to the left of 1. Okay. And over here by the 3, we want everything greater than or equal to 3. Everything greater than it is to the right of it, is bigger than it. So this is what our solution would look like as far as our graph is concerned. All right, so this is the union of these two inequalities. A lot of times they'll also ask you to put your answer in interval notation. So interval notation, again, it looks similar to ordered pairs. It essentially just tells, it's a shorthand way of what are your answers, right? What is your solution space? And you typically look at a graph going from left to right. So if I'm looking at this graph from left to right, my answer is everything from 1 on. This left direction, we have to have an understanding that that is a negative infinity. Just like over here to the right, we know that this is going to go on and on and on and on forever to a positive infinity. So left to right, this is what interval notation looks like. Starting on the left, we have negative infinity. And that's going to go, 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 go until we get here to the 1. That's going to stop. Okay, then we're going to pick it back up. We have this space. So we're going to pick it back up. So we're going to say, hey, this left side, we're going to unite it. That's with the U. We're going to unite it with the right side. On the right side, it picks up at 3. And then it's going to go, 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 go all the way to a positive infinity. Now, when it comes to interval notation, we got to pay attention to what kind of parentheses, brackets we have on our problem. And that, again, just falls with your symbols here. Less than or greater than is always parentheses. Okay? Or less than or equal to, greater than or equal to represents brackets. Has the same exact meaning of open dot, solid dot. Bracket means you can include it. It's a solid dot. Parenthesis is an open dot. So over here, negative infinity. Or let me add one more thing. Infinities will always have, infinities will always have parentheses because you can never reach infinity. You can never get to it. There's always going to be another number, right? So by this infinity and by this infinity, I'm going to put a parentheses. By this one, we had an open dot. Open dot is also a parentheses. Over here, we had a 3. 3 was a solid dot. It had an equal sign on it, so remember that means a bracket. So this is our interval notation for it. Essentially, again, it just says that our answers are from negative infinity to the 1, and then it picks up at the 3, goes off to a positive infinity. Okay, so you have to solve it, your graph, and then your interval notation. A lot of times, all of these are counted as your answer for this problem. So a lot of times you need to make sure that you do include all of that and remember the notations for it. I do have other videos on just understanding on how to do the graphing and just solving regular inequalities. So if you need a little bit more explanation than that, go back and watch one of those videos.